Hello everybody, this is Mika Seppälä. In this video I discuss ways to compute areas of domains by integration. Recall that by the definition of the definite integral, the area of a domain between the graph of a function f and the x-axis of the interval from a to b is the definite integral from a to b of the absolute value of f of x dx. Here in actual computations we need to split the interval from a to b into subintervals such that the function f does not change its sign over these subintervals. So in each subinterval the function f is either non-negative or non-positive, and therefore we can simplify the absolute value signs away and hence perform the integration. Slightly more complicated situation is that we have to compute the area of a domain bounded by graphs of two functions. So here in this example we have graphs of functions f and g, and they bound a domain. The area of this domain is the integral from a to b of the absolute value of f of x minus g of x dx. Here again in actual computations the interval of integration from a to b needs to be split into subintervals where this expression f of x minus g of x does not change its sign, and over such subintervals the absolute value signs can be simplified away and the integration performed. As an example of this type of computation, let us solve the following problem. Find the area of the domain bounded by the graphs of sin of x and cosine of x for x between pi over 4 and 5 times pi over 4. Here in this picture the red curve is the graph of the sine function and the blue curve is the graph of the cosine function. We have to determine the area bounded by these two graphs. By the previous formula, the area of this domain is now integral from pi over 4 to 5 times pi over 4 of the absolute value of sin of x minus cosine of x dx. Between pi over 4 and 5 times pi over 4, sin of x is greater than or equal to cosine of x. That is, sin of x minus cosine of x is non-negative throughout this interval. Therefore we may simply strip away the absolute value signs and observe that the area is the definite integral from pi over 4 to 5 times pi over 4 of sin of x minus cosine of x dx. This is easy to compute now. It is a substitution from pi over 4 to 5 times pi over 4 to the function minus cosine of x minus sin of x. And this substitution gives at the upper limit 2 divided by square root of 2, because both cosine of x and sin of x take the value 1 divided by square root of 2 or negative 1 divided by square root of 2 when x equals 5 times pi over 4. At the lower limit we get minus 2 divided by square root of 2, but we subtract the lower limit, so we get from the substitution 2 divided by square root of 2 plus 2 divided by square root of 2, which is 4 divided by square root of 2, and simplifies to 2 times square root of 2. So the area of this domain is 2 times square root of 2. In this problem our task is to find the area of the domain bounded by the curve y squared minus x squared plus x to the fourth equals 0. In order to be able to find the area of this domain, we first need to understand how the domain looks like. Therefore we first solve for y from this equation y squared minus x squared plus x to the fourth is equals 0. We move negative x squared plus x to the fourth to the right hand side and take a square root, so we get that y equals plus or minus square root of x squared minus x to the fourth. And this simplifies to plus or minus x times square root 1 minus x squared. Therefore we conclude that this curve y squared minus x squared plus x to the fourth equals 0 consists of graphs of two functions, namely the function y equals negative x times square root 1 minus x squared, which is the red curve shown in this picture, and the function y equals x times square root 1 minus x squared, which is the blue curve shown in this picture. Both functions are defined only if x is between -1 and 1, and both functions take the value 0 when x is -1, 0, or 1. So we have this graph which looks like the infinity sign, and we have to determine the area of the domain bounded by this graph. So we look at first this blue curve and the area bounded by the blue curve and x-axis between 0 and 1. The area of this yellow domain is the integral from 0 to 1 x times square root 1 minus x squared dx. And we observe by symmetry that the area of the whole domain is 4 times the area of this yellow domain. So we simply conclude that the area of the domain that we have to compute is 4 times integral from 0 to 1 x times square root 1 minus x squared dx. We substitute t equals 1 minus x squared to this integral. When we do that, then dt equals -2 times x dx, that is x dx equals minus dt divided by 2. We have to compute also new limits. When x equals 0, t equals 1 minus 0 squared, which is 1. And when x equals 1, t equals 1 minus 1 squared, which is 0. Therefore, the substitution gives us 4 times integral from 0 to 1 x times square root 1 minus x squared dx equals 4 times integral from 1 to 0 square root of t minus dt divided by 2. And then we observe that this, of course, becomes just minus 2 times integral from 1 to 0 square root of t dt. And now if we switch the integration limits, the sign of the integral changes, so we get that the area that we have to compute is now 2 times integral from 0 to 1 square root of t dt. Now this is easy to compute. We simply substitute to 2 divided by 3 times t to the power 3 divided by 2. We substitute from 0 to 1 and multiply this result by 2. We get that the area of this domain is 4 divided by 3. In this problem, our task is to find the area of the domain bounded by the graph of the function e to the negative x for x greater than 0. This domain is, in a sense, improper because it's infinitely long. It extends all the way to the infinity. Then the question is it still possible that the area would be finite? Now, if the area is finite, then it is given by the improper integral from 0 to the infinity e to the negative x dx. And this improper integral actually does converge. It is a limit as b goes to the infinity of integrals from 0 to b e to the negative of x dx. And these, on the other hand, are limits as b goes to the infinity of substitution from 0 to b to the expression minus e to the negative x. And this substitution gives us minus e to the minus b minus minus 1. As b goes to the infinity, e to the negative of b approaches 0. Therefore, we conclude that the limit of this expression is 1, and that this improper integral from 0 to the infinity e to the negative of x dx converges. This is one of the basic types of improper integrals whose convergence we actually already knew. And therefore, this improper domain under the graph of this function e to the negative of x for x greater than 0 has a finite area. Its area is simply 1.